Hi. Let's do some related rates. Okay, as you know from 9th grade physics, the slope of a position graph is your velocity, and the slope of your velocity graph is your acceleration. So, in other words, you have something like this, okay? So, your position, which let's say is represented by the graph of x squared, the slope of that, or the derivative of that in graph form, would be your velocity. So that's something you just need to know for the bigger understanding of this thing that we call related rates. So now that you know that, let's say, okay, now that you know that, let's say that you have a pole or some sort of thing that doesn't change size leaned up against a wall that is named A, and that is on the floor that is named B. Let's say that this pole, or whatever it is that doesn't change size, is 12 whatevers, okay? And let's say that this point right here is moving that way at 1 whatever per second, okay? So that means that since this is going to stay 12, that this point right here is going to fall at a certain whatever per second. So let's say that you want to know how fast this is falling down at any certain point in time. So how would you do that? Because, like, you might say that since this is going out at 1 that way per second, that this one is going at 1 down per second, but that is not true, okay? So, since that's not the same, guess what? You have to do some calculus to figure out whatever. Now, so what you're really trying to find in this is A prime, right? Makes sense? Because any point of position on this, as it's falling, the velocity of that at any certain point in time is represented by A prime, okay? You need to figure out what you're trying to find, what the question is asking for. And in this case, it's A prime. So, the second step is to figure out what you already know. Okay? So, you know what C is. What the pole named C is. It's 12, right? So you're going to want to write that down. C equals 12. Wow, I'm getting better at this writing upside down thing. And you know, well, you don't know what B is actually, but you know what B prime is. And B prime, or how fast B is, the floor position is moving, how fast that is, and B prime equals 1. Okay? So, your next step in this is trying to figure out what kind of rule or relationship relates everything that you have. So, well, what can you do based off of triangles, hint, that can give you that relates all of those, okay, all of the sides. This is pretty simple. It's just a majestical beast in mathematics called the Pythagorean theorem, which is quite obviously a squared plus b squared equals c squared. That's probably that's the most important part of doing these, pretty much, is just figuring that out. After that, it gets pretty easy. So, since you're trying to find a certain velocity or derivative of something, it only makes sense to find the derivative of that relationship. In the last video I described how to do basic derivatives, but I did not explain how to find derivatives with relationship to other things. Because in this situation, you would just be like, oh yeah, it's just 2a, 2b, 2c. But it's not, and it's actually, you have to find the relationship with respect to time instead of itself, or x, or a or b or c. So that gets a little bit tricky, but all you have to do for that kind of thing is go back to basic rules and use a chain rule. Okay? So the very basic rule of chain rule is f prime of g of x times g prime of x, which I taught in the last one. Okay? So what you need to do with every single one of those terms in the a squared plus b squared equals c squared is just do that. Okay? So you chain rule the a squared to get 2a, and then the derivative of a, which is just a prime. And then you do that for b squared and c squared, okay? So then, that gives you that right there. The 2a, a prime, plus 2b, b prime, equals 2c, c prime. Okay, so now, you have, what you're trying to find is how fast this is falling down this a side, which I conveniently and magically named A. Yeah, because I'm a cool guy, and I just was like, hey, I'll make this easy, and name them easy names. So you're trying to find how fast this falls, or in other words, A prime. And guess what? You totally have A prime. It's right here, okay? It's right there. Right at that circle. So now all you have to do is my personal downfall, algebra. Blah. Cue the blood sequence with flames and demons and whatnot. Because I am stupid and dumb. Anyway, so to get a prime by itself, all you have to do is minus 2bb prime and divide off 2a. Okay? So I'm going to do that little bit of algebra. Okay. So that gives you... Okay. So that gives you that little thing that I underlined right there. Okay? Which is a prime equals 2cc prime minus 2bb prime over 2a. So, now, you see right here, your c side, the derivative of c is 0 because it's not changing size at all. So it's not, since it's not moving, it doesn't go. So it's just 0. Which means that this whole term right here, the 2c c prime, is just 0, since the derivative of it is 0. So you can just pretty much cross that out. So then, you have b prime right here is just 1. So you don't even have to have that term, pretty much, or you could just plug it in for whatever, since it's, you would plug in the 1 right there, and I just give you the same thing so you can just erase it or whatever, but if it wasn't one, then you would plug in whatever it is. And then you can figure it out from, you can just figure it out from there, pretty much. Because in questions, they will give you like a certain number that B is at. And so you would just plug that in for B in your A prime equation. And then you would use Pythagorean theorem again to figure out what A is, and then plug it into there, and then that's your answer. However fast A is moving at that when that is a certain length. Okay. So if that related rates problem were a body of water, it would probably be a lake, like a pretty big lake. And then it's not huge, and it's not too difficult to like boat across or something like that. But you can't swim across it without your calculus boat. God, that was stupid. More bad metaphors. But these get harder pretty quickly, I guess, in that I don't know geometry, so I don't know what relates what. But let's say, I'm gonna bring it back to the original, what I had before, kind of. So you still have A, B, and C, and B is still moving out at 1 whatever per second. And instead of A falling down, A is always going to stay the same height. Oh gosh, 10. Let's say that A is 10. Okay. So that, since A is constant, that means that this side, right? That means that B and C will be changing. Okay. So yeah. But instead of trying to find C prime, we are going to try and figure out how fast this angle changes instead of a side. Your first step in this, again, is to try to figure out what you're trying to find. And that would be how fast this angle right here is changing, meaning a theta prime. So you're trying to find theta prime. So you're just gonna write theta prime, whatever, down there so that you can remember what you're trying to find. Second thing you do is you try to figure out what you have already. Okay, which is A equals 10 and B prime equals 1. So that's everything you have right there. Very poorly written because it was upside down. I'm still not a master at that, so get used to it, I guess. And now your third step is to try and take all of this and connect them together into one godly being of a equation. Okay. Now usually I am an atheist, so this is it's kind of awkward for me. Let's just put it at that. This is valid stuff. I'm just gonna quit this. When you have an angle of some sort and a side, guess what? You have to use trigonometry. What you're trying to find is theta prime, and what you have is you have information on your opposite side, which is B, and you have information on your adjacent side, being c. So that would lead you towards tangent because you have opposite and adjacent. So that would give you tangent theta equals b over 10, or opposite being b over adjacent being 10. So then your whatever step in this is to find the derivative of what you have. Okay? So when you derive that, you get secant. So when you derive that stuff right there, it gives you theta prime secant squared theta, because of chain rule, equals, I'm pretty sure because I don't have my calculator with me at least, b prime times 10 over 100. So then you just divide off the secant squared theta.
Give it to me.
No.
I bought it.
No, you didn't.
I went, okay, pour it in. That's good. That's good.
My dad is stupid. So yeah, you just divide off the secant squared, and that gives you theta prime equals theta. So your theta prime would just be b prime times 10 over 100 times 1 over secant squared theta. You just have to know what to do. Step 1, figure out what you're trying to find that's moving, most likely. Step 2, figure out what you already know. Third step, pretty much a basic geometric equation, pi r squared, the area of a sphere, I don't know, just whatever. Your step, whatever, is to find the derivative of that, and then your step whatever after whatever is to use algebra to figure out whatever your first step was.